All right, so today we're graphing a parabola y equals 4x squared plus 3x minus 7. And there's two methods of doing this. I'm going to go over the first method in this video, and it's using often called the vertex formula, which is negative b over 2a comma f of minus b over 2a. A, b, and there's also another letter c, refer to the coefficients of x squared, x, and the constant. So a, the general formula here for parabola is y equals ax squared plus bx plus c. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. Okay, so that's what we're referring to when talking about b and a and c. So one of the things let me say about this video is that we're going to discuss parabolas that either go up or down, not to the sides. You can also have parabolas to the sides. That's a whole other video, whole other story. So we're not going to go over that. However, graphing, if you can graph a parabola vertically, you can surely do it horizontally as well. All right. So the most important point, arguably, on a parabola is the vertex, which is where it opens up or down, I like to say, or the minimum or maximum values. So let's go ahead and find that first using this formula. So the first thing is to form minus b over 2a. So you're going to take b, which is, in this case, 3, because that's the number that's in front of the x, over 2 times 4, that's the number, that's the a, number in front of x squared, and you get 3 over 8, and then you have this negative just tags along for the right, so you get minus 3/8. All right, so that's the x coordinate of the vertex. The next part is to get the y coordinate of the vertex, which is the f of minus b over 2a. And all that means is that what you got from the first part, the number that minus 3/8, you're going to plug in back into the quadratic equation or function. So we'll go ahead and take that negative 3/8 and plug it in into the function. So it's 4 times negative 3/8 squared plus 3 times negative 3/8 minus 7. One thing to mention, a lot of people will turn fractions into decimals. I highly recommend you don't do that. Over the years, I've seen that people get, the work gets more complicated, as you'll see right now, in terms of the computations with decimals. Not saying fractions are easy, but in my opinion, they work better with decimals, so keep them as fractions is what I would say. All right, so minus 3/8 all squared is 9 over 64. 3 times negative 3/8 is minus 9 over 8, and then minus 7. And I did some cross-canceling here. 4 goes into 64 16 times, so that's how we have the 9 over 16 here, circled in green. And yeah, if you went ahead and took 9/16 to minus 9/8 minus 7, you use a bunch of fractions that you're subtracting, and you'd have to get a common denominator of 16, and you would go ahead and subtract that out, and it comes out to be minus 121 over 16, which is about minus like 7, and I put 3 little dots here because it's like minus 7 and some change. But it's, be more specific, it's 9/16, so it's between minus 7 and minus 8. And that would be the y coordinate of the vertex, minus 3/8 comma minus 121 over 16. Now, a couple of things that I like to do is I like to find the x-intercept and the y-intercept as well as other pieces of information. However, sometimes that's a little hard to do. For the x-intercept, as you see my graphs, the x-intercept basically stands for the graph crosses the x-axis, if that actually happens. And at that point, y is always equal to 0. So that's why I set my equation equal to 0. And I would try to solve. Sometimes it's fairly easy to solve, sometimes it's not. Sometimes you can factor it, sometimes you can't. Sometimes you'll use the quadratic formula, complete the square, whatnot. It's up to you. Yeah, sometimes factoring is out of question, sorry. So it's up to the equation really here. So I'm going to skip that here for a second. And just go to the y-intercept, okay? because yeah, there's a point to me skipping that. I'll go into that in more a second. The y-intercept is fairly easy. It's always x equals to 0 because that's where the graph crosses the y-axis. So if you replace your equation with 0, you get -7, okay? All right, so, and by the way, that curve that you see down here, that's not the actual curve. It's just to let you know what we mean by the y-intercept. All right, so with that being said, you can get a sketch of your graph with this information. So we have the y-intercept, which is -7. So 1, 2, 3, 4, 5, 6, 7, that would be down here. And then we have -3/8, -121/16, which would be like, yeah, that's less than 1, and then I said -3/8, I'm sorry, is less than, it's greater than -1 in terms of size. It's like less than 1, so it's like right here. And yeah, it's somewhere between, the y value somewhere between -7 and -8. And you can technically draw your parabola. Now we know it has to go up. And the reason it opens up is because the coefficient of A is 4. And because that's positive, it goes up. If it was negative, it goes down. Simple as that. Now, I could technically graph this from these 2 points. I'd like to get another one, okay? So how do I do that? Well, maybe if I plug in -1, maybe just plug in something that's to the left of my, of my vertex here. So you have 4 times -1 squared plus 3 times -1 minus 7. So 4 minus 3 minus 7, that'd be -6. So right here is another point. And yeah, a rough sketch would be something like along the lines of this right here. Okay. There we go, that would be your parabola. Now, as I said, the point of me not graphing, I'll speak about not graphing getting the x-intercepts is because when you're doing a sketch, we're often asked just to give like a basic rudimentary graph is what we're looking for. So with that vertex and that y-intercept, you can give a very basic one. However, getting the x-intercepts would make your graph a little more accurate for sure. So if you have, and a lot of the time your professors will ask that, so you have no choice. But if you can get it and you have time to factor and such, I would go ahead and get it just to get more information about the graph. If not, then, as far as it goes. In terms of the graphing, just use the vertex and the y-intercept and maybe another point on here, okay? All right, well, thanks for your time. And for the second part, the second method is going to be completing the square, which is more tedious method in the beginning. However, it pays off because you can grab what the vertex is and the x-intercepts as well from there fairly easily. Okay? All right, thanks for your time again.